Hello, calculus students. In today's video, we're going to learn how to estimate limits from a table. Let's begin with a review of some essential knowledge. So we know if we have limit notation with a small negative up on the exponent of the approached x value, that means that the limit is approaching c from the left. If there's a small positive, that means that we are approaching from the right. And if you don't see a positive or a negative up in the exponent of your approached x value, that means we're approaching from both directions at the same time. So let's move to our example for today. Here we have a table and the directions state, use the values of f of x given in the table to estimate the limit below. Now, this limit given has a small negative up in the exponent, so we know that this is the limit as x approaches 1 from the left of f of x. And that's our first hurdle when it comes to tabular limits. How do we know if we are approaching a function or an x value from the left or right when we're looking at a table? So I want you to think back to topic 1.3, graphical limits. And when we had a coordinate plane, if our x value 1 was on our x-axis and we wanted to approach from the left, we would be approaching from the negative infinity side, getting closer to 1. So all of these values would be less than 1. So the trick to knowing in a table whether it's approaching from the left or right is to look at whether or not the x values are less than 1 or greater than 1. So if we want to approach from the left, that means that we have to find the x values that are less than 1, getting closer to 1. So looking at our table, you can see that our x values actually start out less than 1 with 0.9 onto 0.99 onto 0.999 onto 0.9999. So this means we're looking at these x values that are less than 1, getting closer to 1 to solve for our limit. Now, the question that we ask ourselves with tabular limits is the same question we ask ourselves with graphical limits. As our x values are getting closer and closer to 1, what are our y values getting closer and closer to? Now, it's a common mistake that students would look at this table and say, oh, well, the limit is 3 because the actual value of the function is 3. That is completely wrong. Remember, limits have nothing to do with the actual value of the function at that point. They have to do with the approached value as you're getting closer to that point. So let's look at our f of x values in the table and see what they are approaching. So matched with our smallest value, 0.9, we can see we have 1.230 onto 1.920, onto 1.992, and finally 1.999. Now the question is, what y value are all these f of x values approaching? And the answer is 2. We're slowly getting closer and closer to 2 as our x values are getting closer and closer to 1 from the left. So this means that our left-hand limit as x approaches 1 of f of x is 2. So let's move to the right hand now. Now, right hand would be the opposite of left hand. When left hand, we were looking for the values that were less than 1, getting closer to 1. For the right hand, we're going to be looking for the values that are greater than 1 and getting closer to 1. So starting on this side, our largest x value in this table is 1.1. And we're getting closer to 1 by going 1.01, 1.001, and 1.0001. So this time we're looking at our x value starting with the largest and getting closer to 1 going in this direction. So we're going to ask ourselves the same question. As our x value gets closer and closer to 1, what does our y value get closer and closer to? So we're going to start with our highest x value. It's matched with 3.2, onto 3.02, onto 3.002, and 3.0002 as we're getting closer to 1. as an x value, we're getting closer to 3 as a y value. So that means that our limit as x approaches 1 from the right of f of x is equal to 3. Now, it just so happens that that is the actual value of our function at this point, but it's important to note that even if this was undefined in this table, the actual value of this limit would still be 3. This limit would still be equal to 3 because as our x values are getting closer to 1 from the right, our y values are getting closer to 3. So that means our right-hand limit is 3. So in conclusion, we know that our general limit as x approaches 1 of f of x does not exist because our left-hand limit is 2 and our right-hand limit is 3. And since the two are not equal, the general limit does not exist. Now, to tie this into our topic 1.3, graphical limits, I'm just going to show you the graph of this function. Here we can see that if I wanted to approach from the left-hand side, right, I'd be coming from the negative infinity side and getting closer and closer to 1, which is right here on this x-axis. And you can see that the y value I am approaching is in fact 2. And if I wanted to approach from the right, I'd be coming from the positive infinity side, working towards 1. And you can see that the y value I would be approaching is 3. We do have a jump discontinuity right here, which is why this general limit does not exist.